Hi, in this video, let's talk about a data structure called tree structure and how to implement it. So to start with, we need a class and let's call it node. And let's pass in a constructor and takes in a function, takes in a value called data. And we will name three property for each node blueprint. So the first one is, of course, data equals to data. The second would be this dot parent is going to be a pointer. Let's initialize it with a null value. And thirdly, we have to declare children property, and which is going to be an array of node. Okay, so it doesn't have to be an array. It can be a hash map or other things, but in this case, let's use array first. But just remember that a tree structure and the node structure it uses, they are abstract and they depend highly on the context. So you can manipulate your property and their constraints based on the things that you want to implement. So so node is just like the placeholder in an array, where a placeholder in an array only stores the data, but in this case we also store the pointer to the parent and a place to store the children. Okay. So after node is done, we just need to create a tree, and then let's pass in constructor function that's going to take in also a data, and we will use a constant, and let's call it root node, passing the new node parameter and passing the data that we used. And let's say this dot root equals to root node. And we are done. Our tree structure is done. What's left to do here is just create a bunch of instance methods that's going to store on the prototype function or prototype object, or having a class object where we can declare using the static reserved keyword. So, but before we do that, let's test our solution. So let's just enable this dummy data. So first, we declare a tree object with a tier 1 element 1 value, and then let's add two child node to the parent node and call it T2 element 1 and element 2, and let's also update the parent property of the children to the root node, and do the same for the third layer and update their parent node accordingly. So let's just test out console.log our tree and see what's inside. So it's going to be having a tree property, a root property, and it's going to be a node with two children. So that's our root node, and let's access the children. It's going to be tier 2, element 1, element 2. Let's move on and test out the third layer, one of them at least. Okay, so it's going to be tier 3, element 1 and element 3, element 3 and element 4. Great. So we have created a basic let's say a basic tree structure and initialize some values inside. So now we can write other instance methods based on these values. Okay, so the first thing we do, I think, is going to be a traverse function. So traverse can be having a lot of ways. So it can be depth first traversal, or breadth first traversal. So we can first write depth first traversal, and then we can write breadth first traversal, and then we can write a traverse function that's going to take in a traverse type, and it's going to invoke one of these values or other values if you are interested to add inside. So basically we need to implement our own for loop function for the array, but instead it's a tree because our unique structure does not allow us to loop through every element inside using a simple for loop. So without further ado, let's write our traverse depths first. Okay, so alright, it's going to taking a callback. Alright, and we need to write a function here, and that's going to use the current node. Right, we are going to loop through every element inside the tree. Just remember the concept. So to start with, we need to use, so the current node to start with is going to be this dot root, I think. So the first current node is the parent node, the root node. Makes sense, right? And what's going to do inside is, let's write a for loop, and like I equals to, okay, so we need a name for the function. Let's call it recursive, yeah. So I equals to 0, and I is smaller than our current node dot children. Yes, remember we have a children property. It's going to be array, so passing the length here, I plus plus. Alright, so in here what we want to do is we call the recurse, and we passing the current node and the children property, and passing the index of I. So we can start with the tier 3 element 1, then tier 3 element 2, then go to the parent node of these two and move on to tier 3 element 3, tier 3 element 4, then go to their parent. Okay, so after this is done, we can say that we invoke the callback passing the current node. Yeah, I think that would be the traverse for depth first solution. So let's test it. So it's going to be tree dot traverse depth first, and it's going to take in a callback, and our callback passing the current node. Okay, so current node, let's use it as value passing an arrow function, console.log, nothing fancy, v dot data. Okay, let's print all the data inside our string, our tree. So start with tier 3 element 1, element 2, tier 2 element 1, tier 3 element 3, 4, tier 2 element 2, parent node. Perfect. I think it's done. Alright. Use the same concept. Let's write the traverse for breadth first as well. So traverse breadth first. So it takes in a callback, and let's use a queue here. So let queue equals to an empty array and passing the current node. Current node to start with is the root node, so this dot root would be enough, and also we need current node, so q dot shift. So first thing first out. Okay, yes, correct. So where our current node is not undefined, so this itself is a node, And so don't worry to having a current node that has a false value. So it's not going to equal to 0 or empty string or anything. It's going to be a node, so no worries. And in here, let's say what we should do here is yeah, we should first push the new elements in. So if let our index equals to 0 as well, I smaller than the current node dot children dot children dot launch. All right, plus plus, and passing every children inside our current node into the queue. So queue dot push and current node dot children and passing the index of I. So it's gonna be for loop method, and after the queue is finished, okay. After the queue is finished, what we can do from here is check. No need to check first, just to do the callback and passing the current node. After we passing the current node, we can then say current node equals to q dot shift. So we update the current node by the end of the while block. Then we can use the while block to check again our current node and see if we are pointing to a valid solution, valid value, node value. Okay, let's test out my solution, our solution. Breakfast. So start with tier 1, then do the tier 2, then do the tier 3. I think it's good. Okay, then we can write our traverse function. So traverse taking okay, a callback. So this time let's put in traverse type. And if no values are put in, we will use depth first. So let's check if traverse is just traverse. Okay. Equals to df. It's going to be this dot traverse depth first search callback. Same thing. Else if traverse type equals to our breadth first search. In this case, let's do traverse breadth first and taking the callback. Yeah, I think that's good enough. Let's test out our solution. Okay. Okay, so first is gonna be the depth first search. All right, and if we put in a specific value here, so for example bf, save, it's gonna be breadth first search. Okay, cool. So now after the traverse function is done, I think it's safe to say we can move on to write a simple include function with the things that we used here. So value traverse type equals to default depth first search. So we need to use the traverse here. So this traverse passing the callback, passing a callback, and passing a value here. So it's going to be v dot. Let's passing an arrow function first and passing the traverse type in case we forgot. And actually in here let's update these two functions so that they won't put in is done parameter so that it won't run itself over and over again redundant moves if we already find what we have already what we needed. So for example in here we want to check if our tree structure has this value, has a node with this value, right? As soon as we found that value, we should stop running our traverse function, right? So, let's write the function first and worry about the complexity later. Okay, so in here, if our value dot data is equals to our value, then let is equals to false first, then it's include equals to true, return is, yeah, I think that's going to do it. Let's test our solution and let's write an optimized version of it. Okay, so console.log tree.include. I will say that let's test out this value first. So it's going to be true, and if say 3, 0, false. Okay, I think that's going to do it. Let's not test for to save some time. So the problem is here, let's say if we still we put in console.log here, and let's log the v.data. It's going to run through all the elements inside our tree structure and then print out the value we are looking for, whether we include or not. And we don't want to do that. We want to, so for example, we want to find T3 E1. Since it's the first element we check, we should stop all the things that are followed by that and return true directly without running this callback function repetitively. So one thing we could do that I can think of is update the traverse depth first and traverse breadth first. So let's write it. Let is done. Okay, there are certainly other ways. If you think, if you have a better solution, so please let me know so I can update the solution from my way to implement it. So it's done false, and let's check here if is done is equals to false. We run the callback. If else, we return. Okay, so in here we can do is done equals to callback ternary function equals to true. If it's true, then return true. If not, return false. Okay. And let's copy and paste the same thing for our breadth first search. Yeah, I think we cool. Just ensure to put a comma here so that it won't, the interpreter won't misread our code. Let me check again. Okay, so in here, you just need to make sure our callback returns a value, right? So returns true or something. So in here, console log v and equals to true, return true. Okay, I think that's good enough. Let's test our solution. As you can see, our T3 element 1 is here. The other elements is it didn't run the callback. Great. So let's do put in second parameter and check BF breadth first search. Okay, we forgot to implement the let. Okay, tier 1 first, tier 2 element 1, tier 3 element 1, finish. Okay, finished. Include function is finished. Let's move on to another function. We are only left with two functions that are prepared, pending to be implemented. Add function and remove function, pretty basic ones. Okay, let's do it. So add function needs what? Needs a value to be added and needs a parent value and also need a traverse type. And let's use the default of depth first search. Okay, and in here, if let's say, okay, let's find the parent value first. So we need to declare a parent node and yeah, leave it there first, undefined. And let's run traverse. So this dot traverse and passing the callback. So let's say it's an error function first. Then let's run traverse type passing and so let's check. So if our v.data is equals to the parent node, right? Our we set the parent node equals to our, sorry, my mistake. Because parent value to our v, and we return true. Stop the callback being repetitively running, executed. Sorry. Okay. So after this traverse is done, our parent node should be returned, and let's check if it's being returned or not. So if it's being returned, then we just need to push in a new value inside, right? So parent node dot children dot push. New node is our value, right? But let's just declare a child value since we need it. Let's child node, new node, and passing the value and child node dot parent. Let's say it's the parent node. Let's pass it. Yeah, I think we are done. Let's test our solution by, okay, so we could say tree dot add. Let's add another tier 3 element, tier 3 element 5, and I think it belongs to our tier 2 element 2. And yeah, let's not use any function first. And after this is done, let's use this function again, test out if we have successfully add our solution here. Okay, let's check tier 3 element 5. That's great, and it's being traversed in the right order. Okay, this should be provide a clearer version, and we can also add another tier 2 element, tier 2 element 3, and passing the parent node. Okay, tier 2 start 1 2 3. Okay, correct. I think our solution is good to go. So let's move on to the last function, the instance function that we prepared, and it's called remove. Okay, so remove only needs two things: node to be deleted, so we pass in the value, and also the traverse type. Okay, set the defaults to depth first search. That depth first. Okay, so in here, let's say, okay, so the way we want to delete our element is to find the element first and get the parent, and from the parent's children array we remove the index of that, we remove that value from that array. So with the procedure clear, let's write the function. So value should be like node to delete. Okay, and then let's call the traverse function, passing our value v here and passing the traverse type. Okay, so in here, if our v dot data is triple equals to our value, then we declare node to delete equals to our v. Perfect. So then we return true. Stop the traverse from running the callback over and over again. Okay. All right. So this is finished. Let's say what we do next. All right. Get the parent. So let parent. So okay, if our node to delete is true, meaning it's not undefined, let parent node equals to node to delete dot parent. Okay, so let's then check the parent node. So if parent node is not true, meaning that it's the root node, then we should stop the running the application, because we cannot delete the root node. Or we can, but it's not the right way to go usually. So we only execute the delete once we know that our node to delete has a parent node. Okay, so parent node dot. Okay, so we say let index of node to delete. Okay, this is too long, so index to delete should be equals to parent node dot children dot find index passing a function. So we value return value if it's equals to the value we pass in here. Okay. Then we should do something like parent node dot children dot splice and passing the index to delete. Okay, almost did something back here. So data, make sure it's data. Dot. Okay, index to delete. Then we should only delete one element. Yeah. I think it's done. We can put in more feedbacks during these hooks, but it's up to you. Right now, we just want to write the function. So without further ado, let's do tree dot remove test. Let's remove the tier 2 E3 first. Yeah. So tier 1, tier 2, E3 is no longer there, as you can see. And let's remove the T3 E5. We add it here. Okay, with breadth for search. Okay, as you can see, the T3 E5 is gone too. So basically, this is how we can write a simple tree structure in JavaScript. I hope you like it, and thank you for watching.